Good morning, everyone. I hope you doing well. First of all, I would like to thank the organizer of this conference for giving us the opportunity to present our work. So today I have the honor of speaking to you about study entitled "Explain School Absenteeism in Morocco Using Teams 2023 data." A deep learning and explainable artificial intelligence approach. So, in this presentation, we will explore together the contribution of artificial intelligence in the field of education. We will begin with a general introduction, then define the objective of our study, and finally present our methodology based on autoencoder. With we will conclude with a discussion of the results obtained in their application. In introduction, school absenteeism, particularly in core subjects such as science, mathematics, and language, has become one of the major obstacles to educational success in Morocco. Despite the effort made by teachers and educational authorities, this phenomenon continues to affect a significant number of students, compromising the continuity of learning and widening performance gap. So, to develop an explainable predictive model that identifies the key factors associated with school absenteeism using Teams data, and to inform decision maker about the priority level for reducing this phenomenon. The Teams database is a survey that focuses on several factors. In other words, the Teams database is centered on the multiple aspects, including the factor related to the student performance, the social economic elements, the cognitive factors, the learning environment, and so on. Teams, the trend in international mathematics and science study, is an international assessment conducted every 4 years by the International Association for the Evaluation of Educational Achievement. Its main objective is to evaluate student performance in mathematics and science on a global scale. Morocco has been participation in teams since 1999. Teams exist in two versions: the paper-based version, which is the traditional methods, and the electronic version called eTeams. It's all began with a random selection of school and students in order to answer a nationally representative samples. This selection is carried out according to a rigorous protocol defined by association. Here are some examples of standardized tests. A few examples of questionnaire attending for students, the questionnaire attending for teacher, and finally the questionnaire attending for the school principal. We distinguish here three main categories of data, all derived from standardized tools developed by the association. The first, student data. This comes from the two key sources: the result of standardized tests in mathematics and science, as well the student questionnaire, which cover aspects related to their environment, study habits, and attitude toward scientific subjects. The second, the teacher data, are extracted from the teacher questionnaire, which provide information on teaching practice, training, professional experience, and available resource. Third, school data are collected through the principal questionnaire. This provide information on the administrative context, school infrastructure, and over education climate. We can see that the measure of the variable exactly 488 come from the data collected from students. This variable mainly concerns their personal background, their attitude toward mathematics and science, as well as their learning behavior. The next we have 154 variables from the teacher, which provide information on their experience, teacher methods, and perception of classroom learning. Before going into the data of results, let us first look at the method used in this study. This slide shows the overview workflow of our study. We started with database configuration for data storage, followed by data process where we generated the target variable and cleaned the data. In the third step, we applied the encoder to reduce dimensionality to 10 latent dimension. Then in step 4, we determinate and establish the latent space. Next, step 5, we train to different machine learning model on this latent space. The step 6 focus on evolution and comparing the performance of this model. And step 7, we estimate the importance of the variable using the shape method, which help of better understand their contribution. Then in step 8, we apply the decoder to project the result back to the input space. Finally, we in step 9, we identify the selected the 10 most influence variable that explain student performance. The slide shows the pre-processing step of our dataset. From the initial variable, we remove technique, mission, and redundant ones, resulting in a final set of 596 variables used for the analysis. The original distribution was highlighted unbalanced with nearly 45% in the serious problem groups and only about 5% in no problem. To correct this, we applied smooth method, producing a balanced data where each category represents 25% of the data. This slide presents the model architecture starting with 596 variables. We reduce them through two dense layers down to 10 run, forming the latent space. With the applied classification algorithms such as random forest, decision tree, XGBoost, and SVM to predict and analyze student absenteeism. On this basis, we select SVM as the main model of the rest of our analysis, particularly for identify the most influence variable on academic achievement. Use the shape method. SVM showed the best performance with random forest and XGBoost close behind, where decision tree performance weaker at 0.94. Using shape, we identify the three most influence latent variable like Z8, Z3, and Z2. Choose strong contribution are shown on this violent and future impact plot. Through reverse decoding, we found that key teacher related variable were among the most influence, highlighting the strong impact of teacher practice and classroom condition. These influence variables come from the student, teacher, and school, showing that the math success depends on the whole educational ecosystem and pointing to concrete level for policy action. Student absenteeism and the dropouts are influenced by multiple interconnection factors, including the teacher climate, class size, the teacher availability, the pedagogical methods, the teacher-student relationship, the teacher expectation, the problem-solving approach, the technology resource, and the smart use in class. As shown by the distribution, the 60% of the influence factor come from the teacher and 40% from school, highlighting that the math performance depends more on the educational environment than on the students and calling for investments in teacher training, school infrastructure, and institutional support. Absenteeism is shaped by classroom condition, student engagement, teacher practice, the teacher-student relationship, expectation, and school research, showing that the both pedagogy and infrastructure play a crucial role. Thank you for attention.